great to see you all here. Thank you for those of you who are still with us. I'm delighted to chair this panel this afternoon. My name is Tomás Díaz de la Rubia. I'm the Vice President for Research and Partnerships at the University of Oklahoma. And I have the pleasure to have at this panel a discussion around the future of microelectronics, a critical advanced technology for the United States. And with us, we're very fortunate to have three outstanding panelists. We have Dr. Laurie Giandomenico. She is the Vice President and Chief Acceleration Officer, I love that title, by the way, of the MITRE Corporation. We also have with us Dr. Kearns, who is the Director of Argonne National Laboratory, one of our premier science laboratories in the nation. We heard from Dr. Zachariah earlier. Dr. Kearns leads Argonne, which also has some outstanding scientific capabilities. And Dr. Josef Koller, who is the Senior Director for the Center for Space Policy and Strategy at the Aerospace Corporation. So with that, you know, the National Commission advocates for a whole-of-government approach to innovation. That has been one of Deborah's, signatures from the very beginning of the Council on Competitiveness. And, as part of that national strategy, the Commission has been advocating for innovation in areas like microelectronics for a long, long time. This is really, truly one of our highest priorities in the nation. Fortunately, the CHIPS Plus Science Act has created now an environment in which we can think as a whole of nation, academia, the private sector, the federal government, across federal agencies, how do we bring back to the United States innovation, competitiveness in the space of semiconductors, which we as a nation created to begin with. This is a little bit reminiscent of the conversations back in the 1980s about Japan. Now we talk about China. But the situation is similar. The situation is similar, and the threat and the danger to our economic competitiveness and national security remains, and is very present today. So with that, I'd like to start with some questions for the panel. Along these lines of microelectronics, the future of advanced technology in the US and the CHIPS Act, what do you anticipate will be the impact of this investment on the US semiconductor industry, other leading edge technology industries that depend on microelectronics, and on foreign competition?
Do you want to start?
Well, I was just going to say that I thank you for the question. It's nice to be here and to be joined by all of you. I think obviously we're moving more towards hybridization, where systems companies have more involvement in the design of chips. That's why Tesla didn't have a problem with the chip shortage for cars. They just designed a different chip. So I think we're going to see more involvement of systems companies in designing and developing chips. My hope is that right now, if you think about, the Secretary talked about 50 billion is not very much, 11 billion in R&D is not very much, but very exciting. I hope it influences the rest of the 70 billion that's being spent in R&D and semiconductors globally. Yeah. Right now, that 70 billion, what percentage do we think is actually collaborative innovation? Probably not very high. So there's a huge opportunity to take the 11 billion, demonstrate what collaborative R&D could look like, and potentially inspire the rest of the 70 billion, or a good part of it, to be more collaborative. That also makes it more efficient, right? If two different companies want to do the same thing and they're doing it together, that's 2x your innovation, 2x on your ROI, 3x, 5x. So I think there's a huge opportunity there. And then, of course, private capital is another key area.
Yeah. Joseph?
Yeah, so let me give you a little bit of a space background to this topic. I'm at the Aerospace Corporation. We're an FFRDC. We've been supporting the government for over 60 years with a variety of different space missions. And we've seen the evolution on how the government is buying and procuring semiconductors. And I think that particular aspect to this question is a very important one, because society today and the space economics and the space sector are really very intricately intertwined. You know, who came here today and looked at a map, at a physical map? No hands went up, right? So everybody probably just even just dictated to their smart device, you know, the address of the hotel here. And but that's just one aspect, right? That's just navigation and timing. Other aspects are remote sensing. Other aspects are even science. You know, think of the James Webb Telescope. And national security, of course, is the other one, right? Look at remote sensing and what's happening in Ukraine. We've written a paper ago, a few years ago, on that aspect of remote sensing, overhead imagery, and national security. So these are just some examples why space and society are so intertwined. But why does that matter to semiconductors? Well, a satellite does not run on steam, right? It's not a steam engine. It's highly dependent on electronics and software. And the weight of a satellite is about 20%. That's just semiconductors and electronics, 20% of the weight. If you compare that to a cell phone, it's actually a little bit less. But cars, airplanes, you know, also highly reliant on semiconductors, but their weight ratio is only about 2 or 3%. So the space industry really heavily relies on semiconductors and the microelectronics. And that's why this CHIPS Plus Act is really so important. And as we have observed over the last decades, the reliance, and we can talk about this a little bit more, the reliance on the semiconductors and foreign suppliers and the supply chain, all that, and how the government buys and secures the supply chain, these are all really, really important aspects to it. So I'm glad we had this discussion today with the Sputnik moment, right? You know, as a space geek, that's very dear to my heart. And so I think when we have these wake-up moments, followed by the CHIPS Act, I think it's really going to change how we operate and how we secure supply chain, how we get more manufacturing into the country, and has lots of other aspects to it. So I'm really glad we're moving in that step forward.
That's great. Thank you, Paul.
Yeah, a couple additional thoughts. And to be honest, Josef, I just stand across the street, the JW Marriott. I did pull out my phone this morning and where am I headed, right? And of course, it was just across the street, so a very short walk. But to your point, really become dependent and don't do much today without really checking in that way. So good point. I also wanted to comment on the in terms of the impact, and I think I would be remiss working at one of the Department of Energy's national laboratories. They didn't talk about the Sputnik moment, but also, and really that kind of emphasizes the short-term need, but also want to emphasize there's a longer-term need here as well in terms of not only winning today's battle, but also really achieving U.S. leadership in a sustained way, really in microelectronics over an extended period of time. So important to make both investments. I think to do that, we do need to come together really as a larger community across the nation and really emphasize working together, as Laurie suggested, really thinking about public-private partnerships and really understanding the strengths of all those that come to the table and how best to use those strengths really to the U.S. advantage and the community's advantage.
Very good. Thank you. Thank you all for that. So along those lines, what do you think should be the highest priorities for the U.S. semiconductor industry? And also, how should the government, academia, the federal laboratories, and industry work together to really get us to where we need to be in terms of securing the microelectronic supply chain?
Well, I think there are priorities around advanced semiconductors. So people are talking about what that should look like, but a packaging capability, system on chip, and memory compute. So there are some key areas. We're thinking of them as these are breakthrough challenges. We need to define the challenges and have the National Semiconductor Technology Center be at the crux of working, starting with the problems you're trying to solve, not a facility that can do something in search of a problem. So that's sort of a key one, is what are those big challenges? And then to your question around working together, that I think gets to the structure of the NSTC, the NAPMP, which is the packaging program under NIST, also important.
NSTC is the
National Semiconductor Technology Center. which is at the crux of the R&D spend. And there's been many discussions there about a PPP. It's mandated to be a PPP, but there's many ways to run a PPP, right? So how do you, to me, the most important thing there is how do you strike the right balance of allowing industry to move fast enough to be successful and at the same time be accountable to government objectives and taxpayer spend. You've got quarterly profits, you've got long-term national security and economic competitiveness. How do you balance those two things? And the PPP is really at the heart. How do you create a governance model that allows that to happen? So I think that's going to be a really important piece. At MITRE, we created the Semiconductor Alliance. We've been spending about a year and a half thinking about these problems. But how do we actually put it into action, and what should that look like?
That's good.
Yeah, to me, I like to think of it in tactical and strategic on that spectrum, right? What are the different types of activities necessary to actually accomplish a particular goal? You know, and there are things that we need to start discussing today that will have those long-term implications down the road. So I think, you know, observing what the defense sector and the US government is procuring, in the past, it used to be, you know, like a majority of the semiconductors. But now really the leverage arm that the government has really dropped down to a very minuscule level. It's almost less than 1%. So from a national security perspective, there are very specific needs, right, that semiconductors need to fulfill. If I may bring up a space example again, you know, space is a very harsh environment. There are radiation effects in there that can degrade the electronics. There are single event upsets. So there's particular needs for hardening that is necessary if you want to fly a semiconductor in space. And there are technology advancements necessary to look at that packaging and all the other things that go with it. Now, what the side effect there is all the chips that are flying into space are basically 10 years old. So all the software that's running on these satellites today is actually running on really low performance semiconductors, because that environment is so harsh and there's testing and packaging necessary to accommodate being operable actually in that environment. So, but in addition to that, I think there's, you know, there are long-term implications that we need to, on the strategic level, that we also need to look at, besides bringing manufacturing into the country and those kind of things, but also workforce development, right? And we had this interesting discussion early on. You know, my 12-year-old is a digital native, and most of the stuff he's learning on YouTube, right? He's actually learning more on YouTube than from his teachers, reciting, you know, facts and figures continuously. So that tells me that workforce development and bringing excitement, packaging information to those who are digitally native, to the young mind. So we need to realize that they think differently today. We're part of the old crowd, right? We have learned things differently, very methodically, very deep, but the young generation today thinks and learns very differently. And we need to use that. We need to figure out ways to excite them about the fields that we foresee are necessary down the road. For example, we discussed earlier, there are more people actually moving into computer sciences than electrical engineering. If you look at that ratio, it's going up and down. But software can't run without hardware. Hardware can't run without software, right? And so those are the strategic things that we really need to think about as well.
Very good, thank you. Paul?
Yeah, I would make a couple additional points, and one is, you know, recently, just in the last week, I believe, DoD issued a report from a workshop they held last summer, looking at future directions in microelectronics R&D, for example. And I like that report because it also not only talks about R&D challenges, but also talks about the enablers and really how to really, you know, put ourselves on a trajectory where we achieve those R&D objectives. And so that's where a forum like this, I think, can really bring great value. So I would ask us not only to think about what the challenges are, but how we overcome those challenges collectively as a community. An example of another attempt to do that, which is really playing out real time here, is we've had this conversation today about electrification of transportation, electric vehicles, and there one of the things the Department of Energy has done is really working across the federal government with the various agencies involved and have an interest, but also standing up what they call LiBridge, which is really an industry consortium to work with those federal agencies to make sure there's a rich conversation about the needs and how to achieve those needs. And there were over 600 industry members participating in that conversation with the collective federal government, if you will. And they've just reached agreement on 26 priorities in terms of objectives, and so where it goes from there is yet to be defined, but I think it's a good model in terms of having a lot of people in the discussion, really understanding the needs. My understanding of the needs is probably different, given my perspective versus what an industry participant or member might bring, so important in that way. Also important that we have that diverse community and think about allowing many to have a voice at the table, again, because my perspective is going to be different than a 12-year-old today, for example, or someone that's just really kind of learning the field, so important points as well, I believe.
Good, thank you. I want to follow up a little bit on the topic that has come up a couple times of defense. You know, in the CHIPS Plus Science Act, in the microelectronics appropriated dollars, there's $2 billion to create a Microelectronics Commons in the Department of Defense. Many argue, and I think correctly so, that that's not sufficient investment for the critical needs of our Department of Defense for national security. In this space. What do you think? How do you think we can work together? You know, when we think about whole of government, you know, it's not just the private sector, it's not just commercial microelectronics, but really we need to bring back the supply chain, you know, for our critical national security needs in the DoD. How are we going to accomplish that in this context?
I mean, it is a challenge. I mean, I think we have that challenge at all levels. 52 billion is not enough. 11 billion is not enough. 2 billion is not enough. But what we do know is Commerce is looking at spending 11 billion on research, and that will involve hubs, and that will involve collaborative research. And DoD is putting together 9 research hubs for the Microelectronics Commons with 6 application areas with its specific challenges that it's already defined, which is great, because that really helps helps leap ahead and get everyone organized around collaboration when you know what problems you're trying to solve. Yep. So that's sort of one. The question is, to what extent do other people care about those problems? I do think there's base levels of innovation that can be, there can be collaboration. These two entities, the Commons and the NSTC, what I'm calling runways, NSTC needs to create runways of innovation that aren't just the hubs solving hard problems, but these breakthrough challenges that sit on top are going to be relevant to everyone. How do you improve energy efficiency? How do you improve security? Better memory, right? So all of these areas are going to be important even to DoD. So I think being able to sort of evolve and make sure that those areas are both considered. The other thing I would say is, you know, on the one hand, the Commons is sort of early stage research, but it's also trying to solve hard problems for DoD. So there's a certain percentage of that innovation that will need to be accelerated and commercialized, right? And if we can define that up front and figure out what that overlap is with NSTC and create runways of innovation that others can use like DoD, we can be a leap ahead in making that $2 billion work harder. And I think that will be a really important piece of it. And the last thing I'll say is to inspire additional innovation, not just where the investment of the $70 billion of companies today, but private capital, right? Private capital in deep tech has continued to hockey stick. It was 7 billion, then it was 70 billion. It's continuing to grow. So the amount of innovation in hardware, not just software, as Paul was talking about, is growing. And how do we keep up with the workforce? And how do we continue to train the investment community that these investments are going to be longer term? It's not just a 3-year multiple anymore on software. It's 5-year, 7-year, 10-year, because these are the technologies that are transformative and are ultimately going to unlock value. I think the market's going to eventually get that, but that has to be a parallel with long-term innovation, long-term R&D, and we need to bring the private capital markets in. One last thing I'll say about that, it's teaching them about deep tech. How many private capital investors understand how semiconductors work, right? 50% of the private investment in deep tech is climate change. Why? Everyone's heard about climate change. Everyone, even if they don't fully understand how sensors are going to work, they at least know that's an important thing, and those companies are going to be successful. We need to talk about semiconductors the same way. We need to talk about AI. We need to talk about 5G and why it's important to invest here.
Very good. Anybody else wants to comment on this?
I could go and add another national security perspective to that. I mentioned earlier overhead imagery and what's happening in Ukraine. That is being done with satellite overhead imagery, right? And as I said earlier, that those satellites need to be secured, or the components need to be supplied through a secure chain, right? You don't want to have back doors built into your semiconductor chips on the satellite, because that is really changing the world. There's no more staging area in that sense of where one country can invade another country. You have the satellite overhead imagery, but that's relying on that supply chain, right? That supply chain that is leading to that transparency. So the space sector is actually experiencing something very interesting that maybe is an analogy to supply chain in the semiconductor industry. You know how things are so disaggregated? You have manufacturing, you have packaging, you have fab labs. You know, they're all separately. Design is separately. There's something interesting happening in the space industry. Some companies are actually starting to reverse that disaggregation. Space is actually in particular one of those. They see that there is a certain risk associated to it with not having the security of the supply chain. So they're just bringing everything back into the house and vertically integrating the whole thing. For example, you know, they don't rely anymore on the Navy or the Coast Guard to rescue capsule that land in the ocean. They just basically bought their own Navy or Coast Guard rescue missions, right? So it's that, so they don't have to rely on the DoD anymore to provide that service. So they are just integrating everything. And I think there's maybe something that the semiconductor industry can look at as well, that reintegration that was previously outsourced, that can secure that supply chain.
So let me follow up also on something that Laurie said. And Paul, I want to ask you this question. You lead one of the largest, most prestigious science and technology laboratories in the country. How do we, in the context of chips, there's a lot of discussion on the private sector and sort of advancing current semiconductor technologies. But how do we think about quantum technologies? How do we think about AI, neuromorphic computing, and new kinds of chips beyond Moore's law, future G, not just 5 and 6G, but future G, where we've lost leadership in this country? How does a science laboratory like yours think about this?
Well, it's front and center in the discussion. There's a lot of conversation, a lot of initiative underway. We're lacking a bit in terms of investment and really, I think, broader community engagement as well, due to the fact that we have limited funds. So we need to argue for more funds and gain support to really allow a larger community engagement, more effective response. I think, the investment, getting back to Laurie's point in terms of the investment in hard tech, quantum is one of those technologies where it's really just amazing, right? That how quickly really the venture capital community stepped forward and willing to make investment, not really understanding the value proposition in some cases, but really feeling like they just had to be involved. And so I think the appetite is there. We need a larger investment, I think, as a country, really, in these technology areas. There's quite a bit of thought going on. Let's just pick one of the topics you raised around quantum computing, for example. And you've, with representatives here from Oak Ridge and Livermore and Argonne, you've got, if you will, DOE's first 3 exascale computing systems all about to come into service this coming year, basically, for the user community. Thinking what is beyond that, though, is really what we need to be today. We need to be having that conversation and thinking about neuromorphic, thinking about quantum, and perhaps some hybrid systems might be the next generation of what we choose to move to. So conversation needs to happen. It needs to happen now. We need investment. So,
thank you for that. Yeah. Let's possibly close with this question, which has come up a little bit already, but I want to hear a little bit more about this. Do you think that this investment by the federal government today that is catalyzing this revitalization of microelectronics is going to be sufficient to maintain the momentum in the future? Do you think that we'll have the follow-on private investment to really return the leadership in these advanced technologies to the United States.
Well, I think it's essential that we have the follow. I think of this investment as a seed investment. And so we've got about 5 years to do enough with it to inspire industry and private capital to come along. And the Secretary talked about that, and I was happy to hear it. It's not just $40 billion in incentives. There's going to be a quid pro quo. You've got to put some muscle into it and make some commitments. So I think we know it's a seed investment, but I do think industry is inspired to do that, right? We have to make these big companies successful. We don't have a choice, and they want to be successful. They're passionate about it. And I think the private markets and private capital are sitting by the wayside saying, what's going to happen here? Where should we invest? How can we think ahead? So everyone's paying, and that's the thing I think the Secretary and Commerce have done, and the CHIPS Act overall, it's drawn attention. So that's the other thing that's key. I think now is the time, right? Now is the time for us to rally attention so that in 5 years, we're not saying, oh gosh, what do we do? 50 billion turned into zero, or is 50 billion going to turn into 500 billion? It's our choice. We can, we're in America. We've got a huge innovation, the best innovation engine in the world, right? So we have a lot of opportunity here.
That's great.
Yeah.
Anybody else? Yeah.
Go ahead.
I'm going to jump in as well and offer, it's got to be a virtuous cycle where people realize a return from the investments they're making and see that is really motivation to continue making that investment. It's great, really, the federal government stepped forward, we as taxpayers have stepped forward really to provide the seed funding, if you will, to start that virtuous cycle. And so I believe that's strongly the case as well. So.
Optimism, that's good.
Yeah.
Joseph,
I
you're
think-
optimistic too?
I'm balancing my views. Yeah, I mean, somewhat optimistic, somewhat. I think there's more that needs to be done, right? I'm truly an optimist, but more can be done. I'm wondering about, you brought up the international aspect to it earlier, and we spoke about the workforce development. Where is our 1,000 talent program, right? China has a 1,000 talent program. Where's ours, right? And the manufacturing of semiconductors is highly automated, right? They almost run itself, but they don't, right? They don't run themselves. And R&D cannot be automated. R&D is based on people, on people's mind and ingenuity. Where's our 1,000 talent program?
Very good. Thank you all so much. Very stimulating conversation. Really appreciate your time.
Thank you very much.
Thank you. Thanks, everybody.